Hello, class. I'm here to talk about Chapter 10 problems, or should I say Chapter 10 and then problems. Um, if you have, which you should have by now, read Chapter 9 and 10, you will notice that really once we have work on Chapter 9, we're basically working with one simple mean or right here, or one single proportion. Chapter 10 is going to be jumping into two simple means or two uh, proportions. So right here, now we're going to be working with two population means with unknown standard deviations. We're going to be working with two population means with known standard deviation. We're going to be comparing two independent population proportions. And if we have, I'm not sure if I assign any problems for the pair samples, then you would also be working with that, and then hypothesis testing for two means and two proportions. So what is really gonna change in relation to chapter 9 is that now we're just gonna have different formulas. And when I was looking at these formulas, I thought I'm probably gonna confuse them more. So I rather work on the problems, and you see that really is the same basic concept at chapter 9, but now you're working with two different values. And right here on this example 10.6, there's something very important here that you should learn. It says in this problem, it says since the mean 1 is less or equal than the mean 2, the population mean, then the mean 1 minus mean 2, because you do the difference, then is 0. And we know that the mean for a normal distribution is 0. Therefore, when you look at this formula right here, you're going to be using over here, you're going to be using 0. Okay, you're actually just going to be subtracting sample mean 1 from sample mean 2. So let's go ahead and jump right into the problems so it doesn't become a long video and you see that really it's not much different than what you have been doing so far. I put it as usual on an Excel template. I left all the little tricks here. How do you make your decision? What I have added now is that we're gonna have our sample size. We of course we're gonna have our null hypothesis and our alternative hypothesis, which I'm gonna state. I put it different. I'm gonna state it down here. But you're also gonna be using the sample size. You're gonna be using what kind of distribution. Now you're gonna have different sample means. So you're gonna have right here I put X bar because the symbol is giving me trouble for 1. So in this case, for example, the simple mean, let's call the first one is um, 800, and then the second one is going to be 900. And then you're going to have two different standard deviations, which I have also put as 1 and 2. So right here 95 for the first one, and zeta is going to be 105. I don't know if you say zeta, I'm assuming. Okay. I have put the questions over here, so we don't have to go to the appendix. We're just gonna, in your case, I really just asked for problem 42 and 44, but guess what? Problem 44 is asking to draw a graph, and I told you that if you have a problem asking for a graph, to not worry. So what I did when I put the graph for you over here, and all you need to do is to copy my graph and paste on your homework. Yes, I said that. Copy this graph and paste on your homework, and then you'll get credit for it. Okay? Let's go ahead through the problem and read it. It says that we use the following information for the next 5 problems. I'm not gonna alloys, I guess. So I'm just gonna say metal. Okay, so two metal are being considered as material for ball bearings. The mean melting pot of the two metals is to be compared. 15 pieces of each metal are being tested. 15 pieces, your sample size. And both populations have normal distribution. So right there, you know you're working with a normal distribution, or some words I just seems like a rule for me to misspell it when I'm typing, or your Z table. Okay, the following table is the result, and then you say, okay, how do I determine what is my null and alternative hypothesis? Usually, you're gonna find on your question. Okay, in this problem right here, if you go back to your book, let me show you over here. It gives you all the information, and then is this the one, or is it this is the one, right? No, it's before that. Maybe it's 10.2. There is one, yes, 10.6, 10.2 section, 10.6 problem. Right here, the question is, does the data indicate that wax 1 is more effective than wax 2? So does the data indicate that wax 1 is more effective than wax 2? So is wax 1 better than wax 2? So greater. Well, the symbol that we have here, greater, would be this one. Therefore, your null hypothesis would be less or equal, and then your alternative would be greater. So here we go. For your null, less or equal, for your alternative, greater. So right here, it doesn't tell you exactly, but it tells you it is believed that the second one has a different, here we go, melting pot. It is believed that alloy zeta, I believe, has a different melting pot. Well, in this case, which one here has a different sign right here? So we're going to be using this two for our null and alternative hypothesis. Therefore, over here, one more thing. I just told you that we are working with the mean. Therefore, this is not a proportion. It's going to be a problem. And if you go back to your book, section 10.2, two population means with known standard deviation. Here we go. We have two population means with known standard deviations. Therefore, we're using the normal distribution with the mean. So your null hypothesis is going to be the mean. You know what? Let me include this and you're going to see why. I just don't want to have to open this several times. I'm going to open here. So you know that your mean is equals, I mean, there, if your alternative is different, then right here, the mean one, is the mean one equals to 2, or is the mean one different than mean 2? Here we go. I could just write mu, but I really want to you see the symbols. This is your problem to solve, which you're gonna see. It's gonna take you a minute. Is this a right, a left, or a two-tailed test? Well, if you remember that I told you so many times and I did a whole video on it, best way to remember the difference with the two bars. So all you have to put on problem 42 is this is a two-tailed test. As simple as that for problem 42. 43 is the longest one that you were not asked to solve, which I'm gonna show you how to do it for future reference. Okay, you're gonna need this. It looks like a crazy formula, but really we're just adding a new simple mean, a new population mean, and a second standard population standard deviation, and a second sample size. You really did that several times, but now you have two values. And if you do remember, I just told you that this value is going to be 0. So really, what we're going to be doing, it's going to be, and that's why I put these values over here. Where's my simple mean? I'm going to do by the numbers. Simple mean minus this simple mean 2 right here. Simple mean 1, simple mean 2, correct? Remember I said here is going to be 0 divided by, and then we're going to square root. We're going to have a 95, which is the standard deviation 1, to the second power divided by the sample size, which is 15, correct? Plus the standard deviation for the second one right here. I'm on this portion right here, over here, raised to the second power, carry 2, divided by my sample size. Well, I'm missing parentheses because all this is square rooted, and there we go. That's the value that I was hoping to get. We can go ahead and just leave it. Let's leave it at 3 digits. If you do remember from your previous videos, I just determined your Z statistic, okay? But it's asking for your p-value. So if you do remember, now we're gonna have to go to the table, to the Z table, and look up this value in order to find our p-value. And just keep in mind, we are working with a two-tail, so that value will be multiplied by 2, because on right here it says draw the graph of the p-value. You notice we are working with both tails. That's why we're not just being asked one tail. Okay, so let's get your Z table out, and we're gonna be looking for a value of minus, which I had worked on before. However, I want to know you notice that right here we could just round this up and do a 274. Actually, I want to make it even bigger. Okay, maybe like this. A little smaller than that. 180. Okay, I just want to you don't get confused by all numbers. I could try to get a 274, which is a 0.0031, but I'm just gonna average between a 2.73 and a 2 point, actually a minus 2.73 and a minus 2.74. So we have 0.0032 and 0.0031. So 0.002 plus 0.0031. And then actually, I'm not going to even average then, because if I need to multiply anyway, then by 2, there's no point for me to average. Only if I would just work, if I was just working with one tail, then yes, I could average then, and then that would be my percentage instead of this. But since I'm working with both tails, and I would have to multiply by 2 to cover both tails, so let's just leave it actually at as a p-value. So now you could say, you can move it even a little further and say that your p-value is 0.0063. Here they use 0.0062 when I use an actual website to get the graph for you. Okay, so you don't need to do that, but you would have to have it to do to answer 44, which I have put it for here for you, and I told you you can go ahead and copy and paste to your work. I might even leave it here to make it easier on you. Okay, so draw the graph of the P. I found the P value. I want to show you how to calculate it, and it's graphed. So now is the important part. Okay, so if you do remember from all the way up there, your alpha, right? Or let's read over here. At the 1% significance level, what is your conclusion? So your alpha is at 0.01, so 1%, but this value here is even less than 1. 1% will be over here, 10% will be over here, 1% over here. Here is actually not even 1% right here. So therefore, 1%, this value over here then is less than, actually the alpha value is greater than my p value that I just determined. So if my, which I left here from a previous problem, so if my alpha in this case is greater than my p value, what do? We reject the null hypothesis. For we have, or there is sufficient evidence. I don't like when it does that. Let me see if I can just merge in this. Sufficient evidence to reject the null hypothesis. Then if you go back to the null hypothesis, what it says, that it says that the melting pot for 1 is equals then the melting point for 2. Well, in this case, the data support that the melting um, pot for, let's use their names, Gum and Zeta. Okay, so the melting pot for right here, uh, Aloy Zeta is different than the melting pot um, point, not melting pot, melting point of Aloy Gamma. Apologize if I said, thinking about the restaurant here in San Antonio. Okay, so let me put it here like this, make it bigger over here so we can read it all. Here we go.